In 1967, mathematical physicist Roger Penrose set out to completely rewrite the laws of physics. He wanted to scrap standard space and time entirely in favor of a pure geometric framework. He called it Twistor theory. Instead of treating the universe as a collection of isolated points, Penrose proposed that moving rays of light were the true, indivisible building blocks of reality. When mapped out mathematically, these light lines lock into a perfectly uniform, left-spiraling structure. It flawlessly described certain massless particle fields with absolute mathematical symmetry. For decades, physicists viewed this as an elegant masterpiece. It looked like the exact kind of math needed to finally bridge the gap between quantum mechanics and gravity. But that rigid, beautiful perfection masked a massive problem, a blind spot that would frustrate physicists and stall the theory for the next 60 years. In our universe, particles have an orientation called helicity, which means they effectively spin in one of two directions. You have left-handed particles and right-handed particles. Here is where Penrose's math broke down. His geometric grid perfectly encoded the left-handed fields, but it entirely rejected the right-handed ones. Half the universe was missing from the equations. Penrose named this the Googly problem, a nod to a cricket pitch where the ball spins opposite to the bowler's wrist action. Generations of researchers tried to patch the gap. They doubled the geometry or bolted on heavy mathematical workarounds. Every attempt destroyed the clean elegance of the original framework. A proposed theory of everything doesn't work if it only describes half of reality. To save Twistor theory, physicists had to figure out where the right-handed particles were hiding. Recently, physicist Daniel Tupin realized everyone was looking in the wrong place. The answer wasn't inside the geometry. It was waiting at the absolute edge of the universe. This diagram shows a large sphere representing null infinity. This is the timeless, extreme boundary of spacetime, where massless fields, like light, eventually terminate their journey. When a field hits this boundary, the math dictates it undergoes a specific operation known as the shadow transform. For years, physicists treated this transform as a mathematical curiosity, a quirk on the celestial sphere that mapped a point to its exact opposite coordinate. By identifying the exact physical role of this boundary transform, Tupin reconnected the two halves of Penrose's original theory. Tupin published a geometric proof showing the true nature of the shadow transform. It is the exact mathematical operator for time reversal. The time reversal operator possesses a specific property. It flips a particle's helicity. Mathematically, reversing the direction of time is what turns a left-handed orientation into a right-handed one. This means the missing right-handed particles were always present. They simply reside in the mirrored sector of the universe that runs backward compared to our own. These two sectors communicate directly with each other at their shared boundary, null infinity. This perfectly resolves the Twistor framework without any messy workarounds. The math was right all along. A single geometric reality simply has two sides. Half of our physical world has been hiding in plain sight, functioning in reverse time just on the other side of a mathematical boundary. If half of everything is running backward in time, you might wonder why we don't notice it when we pour a cup of coffee or walk down the street. The answer lies in a phenomenon called zitterbeweging, a strange trembling motion exhibited by massive particles like electrons. Tupin proves this jitter isn't a quantum quirk. It is the physical particle oscillating violently between our forward time universe and the backward time mirror universe. This waveform chart reveals the scale of the oscillation. Happening at the particle's Compton frequency, a single electron vibrates across the time boundary trillions of times every second. During each microscopic cycle, the electron samples both the left-handed and right-handed versions of reality. Our daily reality isn't isolated at all. The very matter making up our bodies maintains its existence through a constant, rapid vibration across the boundary of time itself. Penrose's Googly problem was never a mathematical glitch to be paved over or ignored. It was actually a structural signpost pointing to the fundamental two-sided nature of the cosmos. Forward and backward time operate as a unified structure inside every particle in existence. If you love diving into the deep end of physics, make sure to like this video and follow the channel for more. Reality reaches its full mathematical symmetry by using time itself as a mirror.